This video, Chapter 1, Functions and Models Overview, is designed to introduce Chapter 1 in Stewart's Calculus Early Transcendentals and to introduce the unit-level learning targets as well. So to motivate our discussions in Chapter 1, we want to imagine what is our goal. In this case, we're going to be working a lot with functions and how they come up in the context of mathematical modeling. So our motivation here, being a student in this course means that you are likely going to be taking further math and science courses. And one of the quintessential examples of modeling involves electric field. So everything that works with electricity and magnetism in some way deals with electric field. If you've taken a physics class before, or if you've ever encountered electrostatics in your studies, you'll know that electric force is something that we encounter in nature, naturally, but modeling how objects that can experience electric field, how they behave, is another question altogether. So, for instance, in dealing with elementary particles, for instance, an electron or a proton, how do they experience and produce electric field? Can be modeled using what is known as Coulomb's law. So, in order to talk about the mathematical construct of the model, we should think about so our model here involves, first of all, what physical quantities and variables are we considering? So in our case here, what we're talking about is the particles themselves that possess electric charge, Q, and in terms of field, because field is action at a distance, we're going to be talking about distance from the charges, R. And ultimately what relates these physical quantities and variables is a function. So if you are unfamiliar with the specifics of electric field, we usually represent them using field lines. Don't worry about the specific context here. I'm not going to expect you to remember all this, but the electric field lines represent what another particle experiences when it's in the vicinity of an arrangement of charged particles, like an electron and a proton. And the closer they are to the charges, the more intensely they experience electric field. So this is a visual representation of that relationship, but fundamentally the relationship actually is that the electric field, which is denoted with a capital E, as a function of distance from the charge itself, is represented using this equation. So a constant of nature K that is experimentally determined, and Q being the charge of the particle itself. And with this, sorry, there's no negative here. That's for potential. And with this is actually our model, even though we have to include some. So this is our function. We have to introduce constraints that limit our model. So for instance, this assumes R is relatively small, but not 0, and positive. So, details aside, we use functions in mathematics and in calculus to develop mathematical models. So that is the overarching view of our exploration of Chapter 1. But as you prepare for learning, what do you need to be successful in this chapter? For one, you need to complete the diagnostic tests. Those are the ones that are in WebAssign. And these are not going to be graded for what, are you particularly skilled at geometry, trigonometry? No, these are tools for us to assess where you're at and what support you need to move forward. There's the support resources, including, let's identify them. Some of them include attending office hours, asking questions from your peers, accessing tutoring through the Learning Resource Center at American River College. And what technology do you have on hand? So if you're watching this video, you are able to access the internet, for one. That's how you were able to get into Canvas in the first place. And also, you are using either a handheld device or computer or laptop, and that may be enough for you to be able to calculate things, or you'll need a graphing calculator. And what are the learning targets? So that's what we're going to cover next. This video in particular is going to feel particularly slow, just because we're introducing everything, and it's not terribly exciting. But let's go over the unit level learning targets. And they're more or less in order in terms of what we're covering in this chapter, right? So A, I'm going to express a function. I'm going to abbreviate in certain parts. So function visually, orally, numerically, and or algebraically. This is essentially the objective of section 1.1. You will know how to identify a relation as a function, how to find the domain and range of a function. Now I'll abbreviate again. We're going to determine the parity and symmetry of a function. E, we're going to find intervals of increasing, decreasing. All of this will make more sense once we actually learn or review these topics for a function. We're going to learn to identify and distinguish between basic families of functions we're going to perform basic operations on functions, including composition, transform functions, and relate the parent and their child, and lastly, we're going to find the inverse of a function, if it exists. And so our tasks and assessments here, first of all, you are going to be reading the textbook and watching these videos. This is one of them. And you're going to be doing the web assigned homework as well, right? So those are, that flow specifically is designed to help you in the service of these unit level learning targets.